welcome to our poster session, Optimizing and Evaluating Washington's Prescription Monitoring Program, Data Entity Linkages. My name is Van Schoen. I'm an epidemiologist at the State Department of Health, Prescription Monitoring Program. So just to start off with, when we talk about data entity linkages, we're talking about identifying and classifying records that belong to the same patients. There are usually four different methods that are used: deterministic, probabilistic, machine learning, and referential methods. Deterministic methods usually involves that you construct a set of rules that you believe to be a match. So it might be that two individuals who has the same first name agrees, then you might say that is a match. Probabilistic usually requires that you do little computations of what you expect to be, how many records do you expect to be a match, how many records do you expect not to be a match. Machine learning is you construct a math model that basically comes up with patterns for determining whether two records are a match or not. And referential methods is shown here simply because it is a type of method being used, but what it usually involves is requires that you link data to an existing set of data. So usually what that also means is that you have to use deterministic, probabilistic, or machine learning in order to link records. The other thing, now what we did was we took data from two different quarters of our PNP, the end of 2018 and the start of 2019, and we tried to determine if which of these methods might lead to the most number of matches, so that we don't have to manually review as many records. But more importantly, also how do they compare with each other? And what you see in the middle is that machine learning and probabilistic were, of course, the two that perform the best. But of course, machine learning might have a slight advantage to the probabilistic method, simply because probabilistic method usually requires that you know beforehand what the expected match rate is. And if you don't know, then you have to just randomly guess what it might be, and then manually review the records afterwards to make sure that they were correctly linked. But since that's not always the case, right? If you have millions and millions of patient records, you don't have time to go through even several tens of thousands of records every quarter in order to determine if the probabilistic method was correct or not. And so that's where machine learning comes in. With supervised machine learning, what you do is you create a training data, which is a random subset of the data that you might already be trying to link together. And then you manually review the training data, and you decide if something is a match or not a match. And then you run a math model. You create a math model on top of that, and the math model try to find the patterns in order to get the predicted decision to be similar to the choices that you made. So what that means is that the model will find the patterns that will try to reflect the choices you made, essentially, when you decide two records should be a match or not. And then you use that model on new sets of data to decide if two records should be linked or not. The advantage of machine learning, in terms of what we found, was, of course, that you don't have to manually adjust the probabilistic weights every time. You don't need to know what the expected match rate is if you can assume that the training data that you develop is representative of the patterns that you expect to find. And of course, what we found in the bottom left-hand side, what you find is that machine learning had the lowest number of unique patients. What that means is that it was able to put more records together than any of the other methods. Deterministic was the worst performing one, simply because it was probably too restrictive. The algorithm is one that is used by our vendor, and it requires that zip codes be an exact match as well. And so what that means is that if individuals move, then you might not consider them to be a match anymore. So because of that, deterministic was probably the worst performing method. Now, the advantage of doing all of this and getting a high level of accuracy and be able to do it quickly allows us to be able to track patients over time. Now, we get data every quarter, but of course the indicators that we're looking at for public health are tracked over a course of a year and multiple years. And so we have to be able to link patients together over a long period of time in order to make sure we have a complete history of their prescriptions. There's still the issue, sometimes the challenge of hard to link patients. And these are very, very, very rare. So hard to link patients are, for example, twins, where they might agree on everything except for just the first name. And so what that means is that all these methods tend to assume that twins are always a match, but unless you know beforehand who is a twin or who isn't a twin, you have no way of knowing if two records should be a match or not. The limitations of all this is that we don't actually have a gold standard, so we don't know truly if two records should really be a match or not, because we can't go in and interview every single patient and decide, did we match you correctly? Nor do we have another set of data that'll tell us that, this is correct or that's incorrect. And even if you had a gold standard data set on the side, in order to compare it with your data, you still have to do some sort of matching between the gold standard data set and your data set too. The only way to really decide if a record was correctly done is you just have to come up with a consensus. So in this case, if the probabilistic method and the machine learning method show that this is a match, then we just assume that is potentially a true match. So it's the 2 out of 3 rules, essentially. And of course, if all 3 rules decides that this patient is a match, then we know that it must be truly a match, because there's no other way, given the information available. Of course, if we have more information available, then you might be able to come up with new models or new ways of deciding if patients are a match. This is really quickly, just for this poster. If you have any other questions, or if you'd like a copy of this poster, you can email me below on the bottom right hand side, and I hope you enjoy the rest of the conference. Thank you.